Hello guys, welcome back to today's tutorial where we shall be starting straight from the serializers. Just a quick recap about the serializers. Serializers in Django are a way to convert complex data types such as the Django model instances or query sets into Python native data types that can be easily rendered into JSON, XML, or maybe other content types. Serializers also provide the serialization, which means that they can convert the request data into complex data types. In our case, the request data will be coming from the Angular frontend. And today, we shall be adding two more serializers, the Lactation Serializer and the Pregnancy Serializer, and work our way all through this tutorial up to the end. So, I shall begin by defining the Pregnancy Serializer class. This class inherits from the model serializer of the serializers. And we have these few fields, the due date, the pregnancy, cow, the cow tag number, and the cow breed. The due date and the pregnancy duration are read-only fields as their name suggests. This makes sense because in our model's definition, the pregnancy and the due date in our pregnancy model are being calculated automatically. So it means that we won't have any manual entry for these ones. And actually, they're just properties, they are functions that are being called when the pregnancy is saved or maybe is retrieved or maybe updated. This line creates a writable field called cow using the primary key related field of the serializer class. This field allows user to specify the cow for pregnancy by using the primary key of the instance. The query set parameter specifies that the user can only choose the cows that exist in the database. This makes sense because if we could have used the normal way of serializing the cow field, that is, using the cow, then using the actually just subclassing the cow serializer, this would make us have a lot of problems because assuming that we want to create a new pregnancy record, this would make it very difficult because it will only need that we create a new cow, and it does not make any sense because when we want to create a new pregnancy record, we do not necessarily create a new cow, but we choose from the cows existing in the database. So that's why I had chosen this way to tackle this. And then we have the cow number and the cow breed. So the cow tag number, that is. So the issue here is when we want to create a new pregnancy record, there was a serious issue because now that we've already decided that we will be only choosing cows by use of their IDs, we will not be able to get their tag number because this pregnancy serializer will only be returning ID and we do not have any attribute of the tag number of that ID. So this is just the ad hoc method. I think this is the easiest or maybe the best way to achieve this because in future we would want to maybe categorize pregnancies based on the cow's breed, or rather get the pregnancy based on the cow tag number. So I use the cow tag number and not the cow name because you remember in our model definitions, the cow class, the name is not a required field, which means that at times it could be blank, but for the tag number it has to be there. So that's the reason why I use the tag number. And then this meta class only just specifies the metadata for this serializer, that is the model for the serializer, and also the all now specifies that all these fields will be serialized regardless of whether it's writable or not writable. And then now we add one more new serializer, the Lactation Serializer class, that would be serializing our lactation model. All its fields are read-only. This makes sense because in our lactation model, all of these fields are being populated automatically. The start date and the end date are being populated using these signals firing. So this one will be checking if there's a previous lactation, so it will end that lactation based on that new pregnancy and so forth. So the end date is a read-only field, start date is a read-only field, and then we have this cow field here that's being serialized based on the subclass cow serializer that we had defined in our previous model, this one up here. So this is a little bit different with this cow field here in the pregnancy. Now this is the logic. This cow field here is also just a foreign key to the pregnancy, just like the cow is also a foreign key to the lactation. But the difference comes here. Whenever we are creating a new pregnancy record, we need to choose a specific cow. And when we are creating a pregnancy record, if we decide to have this cow serializer just as I had explained, here it will allow, or rather it will make sure that whenever we are creating a new pregnancy record, we have to create also a new cow. So That does not make any sense. But in this case, we'll only be just serializing the cow, but only just making it a read-only. So the lactation number is also a read-only field because it will be just added automatically using this signal here as in lactation, and this one here, discrete lactation 2. And so the pregnancy here is also just like a read-only field, but it's actually subclassing the pregnancy serializer. So the logic is the same for this pregnancy and this cow. Each and every lactation has to be tied to a specific pregnancy record. The days in lactation, since the days in lactation, the lactation stage, and the lactation duration, all of them are just methods inside the lactation model. All of them will be read-only because this will be returned automatically, and the meta class specifies the metadata for our lactation serializer. And now that's it for the today's serializers. But one more thing before we move to the views, we will need to refactor this milk serializer class. This makes sense because milk serializer also just has the cow field as a foreign key, just like the pregnancy serializer. And so this will lead to issues at the current state in which it is right now. Whenever we try to create a milk serializer, it will complain about the nested serializer. That is one thing that Django REST framework does not handle, because in this serializer we have the milk model, and technically we also have another cow model inside it, and actually it's not serializing the cow. So all we need to do will be to refactor this model and make it look this way. But now, since we've refactored this milk serializer and actually it needs a lactation serializer as a subclass here, we will now need to put this milk serializer below the lactation serializer. And so if we put it here, I hope it won't complain. Yeah, actually it's okay. So the lactation serializer is subclassed here, meaning that for every milk record, because the lactation serializer, actually we do not need to do the manual entry, it will be done automatically, so we won't have issues with it. We don't need any special specification, or rather any special code. We just only subclasses the lactation serializer here, make it a read-only because it will be done automatically. Yeah, the editable is equal to false. So that's it. Then for the cow serializer, we just implement the same thing that we did for the pregnancy serializer. That is, we'll only be able to choose, or rather the query set will be returning IDs of the cows that we have in our database. Now it will be returning only the IDs of cows that are eligible for milking. I hope you remember. And now, since we now will be returning the cows based on the ID, we will need to access their tag number and the breed. This is because at times you might need to get the milk records of a specific cow, and since now we will not be having the cow serialized this way, we will only be returning the IDs, we will need to apply. So this is just some ad hoc method that ensures that we can retrieve the cow number and the cow breed, because I assume that maybe in future we will want to query the milk records based on the cow's breeds and all that stuff. So the metadata, as usual, or maybe as these others had been explained, just specifies the metadata for this serializer. And then now, with all that done, we will move to the views, where we already have one view from our previous tutorial, the cow view set. And similarly, we will do for these other models, the lactation, the pregnancy, and maybe other views too. We shall add them as the tutorial goes on. So let me begin by explaining this milk view set that will be responsible for handling the CRUD operations on our milk model instances, that is the create, retrieve, update, and delete. Now these are several methods: the list method, the create, retrieve, update, and delete. This will be responsible for handling the HTTP GET requests, where it will list all the cows from our database, and then it will pass them to our milk serializer that would serialize all of them. Now there's a specification of main is equal to true, since this will be a list, and that will return a response object with the serialized list, or rather the serialized data. Then the create method handles the HTTP post request that will serialize the request data, and then checks if they are valid, then save them. But if they are not valid, it will return an serializers instance of serializers errors with the response of 400. This is the bad request response. But if the serializer was saved, it will return HTTP response of 201, meaning that something was created. Then for the retrieve, it will retrieve, actually this also does the HTTP GET request, but it will retrieve a specific instance of a milk record by its primary key. So after it is retrieved by its primary key, then it will be passed to the milk serializer, where it will serialize this, and then it will return a response of that serialized instance of that milk model, or rather that milk record. Then for the update, this will handle the HTTP put request, where it will be retrieving a milk record based on its primary key. Then we pass it to the milk serializer. So the milk serializer will go ahead and check if it's valid or not. If it's valid, then it will save it. But if not, then it will throw errors of status code 400, meaning that that will be a bad request. Then for the destroy method, this will handle the HTTP delete request, where it will also retrieve the milk instance based on its primary key, then send the HTTP delete request. Then after it's deleted, it will return a response object with a status code of 204, meaning that there will be no content, but actually the milk record is deleted. And then for the lactation view set and the pregnancy view set, they're just in a similar way. It's only that I decided to customize the milk view set and the cow view set just to ensure that you get a glimpse of how this operates. So this basically has all this functionality inside it. And so our lactation view set is actually a little bit different from these others, since this one inherits from the model view set, yet it inherits from the read-only model view set. The reason behind this is that I chose this because our lactation model actually has nothing to do with manual data entry, so that's why it's read-only. Everything that will be actually retrieved from the lactation view set will be just read-only. This pregnancy view set is just the same as milk view set. And so now that we're done with writing the code for the milk view set, lactation view set, and the pregnancy view set, we'll go ahead and wire up their URLs. All I need to do is to write the router register. Now we'll start with the milk, then views. This is milk view set, I think so. Yeah, let's start with the milk view set. The IntelliSense in my VS Code is really helping me to achieve this faster. So then the other one too, router register. Then we have to have the lactation. Yeah, views.lactation. I think it's lactation view set. Yeah, and then the last one is the router register. We do for the pregnancy things. Pregnancies. Let's keep it in plural. So views.pregnancy view set. So just like that, we're done, and we'll be able to perform the create, retrieve, update, and delete on the /milk/lactation/pregnancies. So this will be our endpoints. And now, before I just proceed now to the front end, because we already have our endpoints for the back end, I'll first of all add new customized views. These ones won't be under the model view set because we need views such as the calculation of the total amount of milk per day and all that stuff that we'll be using on our admin dashboard. So without further ado, let me dive into the code. And so this is how this view works. We define a get method. In this method, we actually define a variable named today. This will be storing the date of today. I use the local date because this is much more easier, and a lot of errors and all those stuff that could arise due to date calculations or maybe date queries are just thrown away. So we actually now define another new variable, start of today. This ensures that, assuming that today is 20th March, the start of today was 20th March, 12 a.m. So this will construct that date time. We use the combine method from the date time that takes into parameters the date and the time, and this is the syntax. So we construct the start of today and the end of today. That will be now 20th March 11:59. That's what's happening here. The time zone, date time, max time returns that. Then also we get the date of yesterday. So we use the time delta. This allows us to add and subtract date times, just like we're doing this normal maths of the multiplication, division, and addition. So by passing days is equal to 1, this tells the time delta that we will be subtracting 1 day from today. So that is, if today is 20th March, yesterday is 19th March. So we get the start of yesterday and the end of yesterday, similar to how we did of the today. And then now we also define another new variable called the total milk of today, where we'll be filtering the milk records that are available within that specific day. So Django provides a shortened syntax of the underscore range. This ensures that we are able, remember the milk model had a field called milking date, so we'll be able to filter the range of milk records that are available between the start of today and the end of today. Mark you now, you already know that the start of today is 20th 12 a.m. and the end of today is 20th 11:59 p.m. And then we sum the amount in kgs and then we aggregate them. So at times maybe it's just now the start of today, we do not have any milk record, so it will default to 0 because it makes sense that way. And then also we do the same thing for the total milk yesterday. I also added this new variable milk difference, which will be a calculation of the difference between the total milk of today and the total milk of yesterday. Then we use it to calculate the percentage difference, then we round it off to 2 decimal places. And then now the return response of this view will be a dictionary of these keys: the total milk of today, the total milk of yesterday, and the percentage difference. These are very important records that we'll use to populate our admin dashboard. Next in line are other several views that we'll be using in our admin. Starting with the total alive cows, this will be returning the number of cows that we have that are alive in our farm, because a farmer, it's quite crucial that a farmer needs to know the number of alive cows in his or her farm. So this is how this works. We define a get method that actually takes in the request object, then we assign a variable, the total alive cows, that stores in the count of the alive cows. So we filter the cows based on the availability statuses. So here we need only the alive cows. Remember, in our models, the cow model, we have the status choices of the alive, dead, and sold. So that's what we'll be using to filter the alive cows. Likewise, we need also to filter the male cows and the female cows. Here we only have the total number of the live cows that we have in our farm. Similarly, we will also need to maybe have the number of the female cows that we have in our farm and also the male cows. They just work in a similar way. They also define the get method that takes in the request object. Then we now have a variable now, the total alive female cows, that will be filtering the availability statuses of alive as well as now the gender. So this gender is just another additional filtering parameter that's added based on this view that will be returning the alive female cows. Then it will also be counting them. So these are just similar, this one and this one. They'll be returning dictionaries of the female cows or the male cows. And so we move on to the cows milked today view, and we shall be calculating the start of today and the end of today just as we did for the milk today view. So this also defines the get method that takes in the request object. We get the today's date, get the start of today and the end of today, and then we filter the cows based on the start of today and then the end of today, and then we count them, and then we return a response object with the key of the cow's milk today. Actually, this is something that we'll be using in the front end, that will be returning the milk cows, the number of the milk cows. And then we move to the new view, the milk production weekly view, that will be returning the data that we'll be using to populate our chart in the admin to show how there have been milk records throughout the week. So this also defines the get method that takes in the request object. Then we define the date of today as we did for the other views, then the start of the week, but this is a little bit different because we are using the weekday method. This returns the date of today or the day of today in integers format, so that is 0 representing a Monday and 6 representing a Sunday. Then we get the end of the week, so this will tell it the start of the week, that is a Monday, then the end of the week, which will be the Sunday. Now I'm using this 7 because I find it a little bit easier to use 7, or rather the 6 is not working, it stops at Saturday. So proceeding to the next step, now we filter the milk records that are available within that specific week. So we are using the milking date and then the underscore range shortened syntax to specify the start of the week and the end of the week. And then because this is a Django ORM, the object relational mapper, we have the order by method in this query set, because this will be returning a query set actually, so we'll be ordering them based on the milking date. And then we define an empty dictionary of the milk production data that will be storing a group data per day. Then we loop through each and every record in the milk records query set or milk records list that will be provided here. So we check if the day that is already extracted here. We are using this shift time method to extract the day actually from the milk records milking date. So if the day is not already here in this milk production data, that means that this milk production data is rather empty, or maybe that day has no data. Then it will add a milk value pair, that is the key will be the day and then the value will be the record. And remember, this record is an instance of the milk, because actually this will be instances. The list will be just or the query set will just be containing the instances of the milk object. And so accessing this record will be just like you are accessing now a single instance of the milk record. So the milk record at the field of the amount in kgs, so the day, then respective amount in kgs. Or if there will be no day in this milk production data, else if the day is already present in the milk production data, what it will go ahead and do is it will go and check first of all the day, then the total milk, and then now just add the new records amount in kgs. This makes sense because you can have several milk records per day. Now that, assuming that you have 3 cows, cow number 1, cow number 2, cow number 3, corresponding to milk record number 1, milk record number 2, milk record number 3, on a specific day, that's, let's say it's on a Monday. So it will go ahead and first of all check the first record, that will be the milk number 1, and then first of all it will not be there because it will be adding it. Then it will go ahead and check the second record because they're all on Monday. Then now, because it will be there, the day will already be present in the dictionary, it will now add the amount in kgs because that record will be just as an instance of the milk object, and it will now add the amount in kgs to that very specific day so as to aggregate them. And now that we have our milk production data is a dictionary, we'll need to convert it back to list of dictionaries. This is important because it makes it easier to work with the data and present it in a user-friendly format. In addition, a list of dictionaries is a commonly used data structure for representing records in many programming languages, making it easy to integrate with other systems or applications, and in this case, our Angular frontend. And this is a syntax. We'll use the list comprehension where we'll be looping through the records in the milk production data, and then now at the end we'll return a response of a list of the dictionaries in the milk production data that will be used to populate our chart. And then we have this new view too, the pregnant cow view. This will also be returning the count of the number of cows that are pregnant in our farm. So this is also crucial because, as you already know, that with building a dairy application, a farmer needs to know the number of cows that are pregnant in the farm. So this also defines a get method that takes in the request object. Then we define a variable pregnancies count where we'll be filtering the query set of the pregnancy status confirmed cows, and then the date of calving is null is equal to true, because when we create a new pregnancy record, the date of calving has to be null. Makes sense because you cannot provide the date of pregnancy or rather the date of calving when the pregnancy has just been created. The date of calving will be provided in 9 months time also. So when the pregnancy is already confirmed but there's no calving date, that means that the cow is already pregnant, or rather it's pregnant. So we count it and then we return a dictionary of the pregnancies count. Finally, we have the lactating cows view where we also filter the lactating cows based on the availability of the end date. So if it's null, meaning that the cow is still lactating, then it will return true and it will filter the cows and then count them and then return a response object with the lactating cows count. And since now we've already now set up all these views that we need to have in our admin, we'll now go ahead and wire them up. So all we need to do is just paste the URLs for accessing the views. Now it's complaining because how we've imported the views. Here from this directory we imported the views and now we were accessing them this way using this syntax, but for now I'll simply refactor them this way, since this will be making it a little bit difficult. What we need to do is from .views import asterisk. This means that this actually is a shorthand syntax for all. So from the views, from this views file, we import everything, and just like that everything went. And now with this we have all these URLs for the cows, the milk, the crude operations for the cow, the milk, the lactation, and the pregnancies set up using this router. And also this our customized view where we'll be accessing the admin. So our front end will be getting these responses from these APIs, or rather these endpoints. The admin dashboard lactating cows will return the number of the lactating cows or the count of the lactating cows, similar to the live cows and all that stuff. Now that we're done with all these, the URLs, the views, and all that stuff in the serializers, we now move to the front end to consume all these API endpoints. And so now that we have the front end folder, I'll start by explaining the folder structure, because there are a lot of modifications and additions that I've done. And this is my folder structure. The eFarm is responsible for the backend that we've done, the previous tutorials, and now just the first part of this tutorial. And so when we did generate the Angular project, this one here, Angular provided us with the SRC. These ones are provided by default. And there's the app, there's the assets. Then I had customized this models folder and the services folder. So the models folder is responsible for carrying the interfaces and the types of the data that our frontend will have. In this sense, if I go ahead and click into the models folder, I have this dairy app. So, and the reason why I'm doing this is that in this project, we will have several apps such as the dairy, the poultry, swine, etc. And so having the dairy folder with its own models specified makes it a little bit easier to manage and to actually debug if there could be any error in future. So in the models.ts file for the dairy, previously we had the cow interface. Today, now that we added the lactation model, the milk model, and the pregnancy, we also have their interfaces here, where the front end will expect the ID, which is a type of number, the start date, which is a type of date, the end date, which is type of date, then the cow, which is a type of number. This is now the cow ID, that is. Then the cow tag number, the one that I had customized in the serializer, the cow breed, and all that stuff, similar to the milk and also the pregnancy interface. And so moving to the services 2, the services 2 is just having the same structure as the models, where we have the dairy services. And now that for a specific model we'll have several services, or rather the several methods, it's much logical to specify services responsible for the cow, the lactation, the milk, and the pregnancy. And in the previous tutorial, the services had already started with the cow service, and I had actually included some methods. And in this service, we have several methods that I've added actually. The get alive cows, the get alive female cows, the get alive male cows, and the get pregnant cows. So since we know the type of the observable that will be returned from our HTTP request, which will be the type of number, we just assign it here directly. It's not the same as, for example, this one, the delete cow. This one was of any type because the interfaces of the cow had ID, had some fields with maybe the date of birth and other strings, so any was making a lot of sense. So here we just directly assign it to the type of number. Then this just works the same as this, similar to this, and also the pregnancy count. So you might wonder why I've decided to just inject these observable types directly here. So I'll just go ahead and simply show you the type of the data that will be returned from our database from the API endpoint. And Django itself offers a very simple and intuitive way to access our API endpoints. And in this case, our API route from the previous tutorial, we had the cows. Now that we've added the milk viewset, the lactations, and the pregnancies, now we have this additional one. And these ones will be able to perform the CRUD operations, the create, the delete, the put, and the update. And since we had all those other customized endpoints too, we'll go and check them out. I'll just revisit a little bit of the urls.py to get a glimpse of where they are. So the path is, for example, we have the admin dashboard daily milk production. So I'll just go ahead and copy this URL, the admin dashboard daily milk production, and go and check it out. So this is our API endpoint, or rather the root API endpoint. So if we paste that and check it out, so we know very well that this API endpoint returns a dictionary of these three: the total milk today, the total milk yesterday, the percentage difference. So now that our database is not populated with anything, or rather it only has a single milk record of today that I just added, this one here, the 21 liters or rather the 21 kgs of milk. So it won't have any milk record for yesterday because actually I did not populate the database yesterday, as I'm recording this thing just today. And now that we've confirmed that our endpoints for the cows work, now that we've checked the daily milk production, so they just work in a similar manner. So I'll just close this urls.py file, then show you a little bit of the new modifications for the, or rather the new additions for the milk service. I added this method, the get total milk today, that also takes in the total milk today and also the total milk yesterday and the percentage difference, because you remember the endpoint itself returns this, a dictionary of these three. So the observable, actually we only need to specify them because they'll all be numbers. So it's the total milk will be number type, total milk yesterday number type, and the percentage difference also in number type. And then it will return them, all of them, so that our component will be able to access them. Then we also have the get milk cow today, get milk cows today. This will return the total number of the cows that have already been milked. Then finally we have a new method, the get weekly milk chart data, which will actually return a list of dictionaries that will be populating our chart data. And in this case, the observable type is any, because the dictionary will be containing different data types. There will be string, there could be, like right now, it will return data types such as the today, or Monday, Tuesday, Wednesday, Thursday, and then also be the total milk amount that will be numbers. So it makes sense to use the any type. And moving forward to my folder structure, I've already explained the services, so I'll go to the assets. So I created the folder images to store the images that we'll be using statically for maybe the icons and stuff of that kind. For now, I have the cow head and the milk SVG that we'll be using on the admin side to at least make it aesthetically beautiful. And then now in the main folder, the app folder, we had the dairy folder. And then in this our dairy folder, I've created new folders for the lactation, the milk, and the pregnancy. These are responsible for handling anything to do with the lactation, anything to do with milk, and anything to do with pregnancy. And also one additional one for the admin. And so in the admin folder, I have the analytics responsible to show the analytics that will be needed or much needed in our admin side, and the dashboard. This will be responsible for showing anything that we'll need to quickly have a glance at of our farm. And so with that explained, now I'll go ahead and explain the code and then start with the dairy app. So in the dairy app, we have one new folder, the milk folder, and it has these components, the dairy milk create. So I'll just simply use this as an example because all these other components just use the similar stuff that was in our previous tutorial, or rather in this tutorial too. So in the dairy milk create, we have this component, the dairy milk create component. And just a quick recap, a component is defined by this decorator where we specify its selector, the template URL. Actually, this component will be getting its template from this directory, that is the / means that this current directory, and also the styles for this component will be found in the dairy milk create component.css. So the meaning of this selector actually is just like an identifier of this component in the HTML markup. So in this component, we first of all define a new milk instance. This one will be storing the milk instance that will be entered in the form that we'll be having to display in our milk creation page, and also the cows. And in the constructor, we inject the three, the milk service, the cow service, and the router. All these are important because you know that in order to create a new milk record, we will need to access the endpoint that is provided by this milk service. And also we need to assign that milk record to a specific cow. And after saving that milk record, we need to redirect the user to somewhere that will be provided by the router. And so this ng on init is a lifecycle hook that is present in this dairy milk, or rather this dairy create component, dairy milk create component, that will be initialized as this create component is also called to. So what we do is that as we initialize this create component, we actually retrieve all the cows. Remember, in the cow service, we have the method get.cows that actually returns an observable. And then this is like storing the observable in the variable cows and then subscribing, or rather adding it into the cows array, this one here that we had already added as a property to this component. And so on submit is a function that we will use in our form that will be triggered actually as an event to ensure that the milk record is saved. So in this case, what we do is that we first of all check if the cow is selected. So if the cow is not selected, then it will return an alert, please select the cow. And if the cow is already selected, what we do is that we take that new milk record and then we pass it to the create milk method of the milk service. Then it will save it, and then we redirect the user to /dairy.milk. This is the endpoint for the milk list. And so I'll just also quickly just go to this dairy milk list too as well. Works just in a similar way. It has the component with the selector, the dairy milk list. So we'll be able to access anything to do with this dairy milk list component. So first of all, we initialize an empty milk array. And then what we do here, because we only need to list the milk, we don't need any other thing. What we do is that we only inject the milk service. And now on initialization, because this is just a lifecycle hook in this component, all we do is call the get milk, which will actually return an observable where we assign them to the milks variable, and we use this milk variable to just like add it to the property of this class of the empty milk arrays. And so it will return a list of milk records in our database. And so that's it for the new components that we've added today, because they're quite similar. They are just like the same thing even in the milk update component. We just actually, this has a lot of stuff that I need to explain. So the component decorator as the others two, then we define the class, or rather the component dairy milk update component, where we define first of all a property, the milk property of a milk instance. This will be storing the milk that will be entered in the form, then also the cows, since for the update we need to have the cows list too as we update the milk record. So we inject the milk service, the cow service, the route, and the router. These are different because this route will enable us to extract the ID of that specific milk record. Then the router will be used to redirect the user to a page after updating it. In this case, it will be the listing page. So that's how it works. And so with all that said, I'll simply now quickly go over through the admin folder where we have some other components too. And in the dashboard folder, I have components responsible for the total alive cows, total alive female cows. They are just similar, but I'll also just quickly go through the first one. And in this component, we store the number of the alive cows. We inject the cow service because that's what we need in this component to extract the alive cows, because the get alive cows is a method in this component, in this service. What we do is that we subscribe the response to this property of this component. Now, because our observable at the property of the total alive cows, this would go inside this total alive cows, and we'll be able to use it in our templates. So this is just similar to this total alive female cows. They just work the same way. Now here, the only variation is that now we are using this method get alive female cows, similar to the get alive male cows and the rest. So this is a template, for example, for the total alive cows. This is a template that we'll be using. So what we have here is just basic tailwind styling, and we pass in the variable that we are defined in our component, the total alive cows. So if you might be curious enough, or rather if you're curious enough and you're wondering where this total alive female cows came from, this is a way in which Angular itself avails the component here by use of the selector. I told you that the selectors are unique identifier for specific components. So in this case, while we are displaying the total alive cows, we also want to display the female cows and the male cows just beneath the property, or rather the count of the alive cows. And so I do think that for that is just enough, and I'll go into the analytics. So in the analytics, for now I only have one component, the milk production weekly chart component that will be consuming the data that we had in our endpoint. This component is just similar to the others in this way. It's only that there is some additional data or rather some additional code that's injected in it. So I'll only explain the differences. For example, right now we have the @viewchild, which is a property decorator that actually ensures that the canvas, that is the chart that will be displaying each and every time that there's an update or maybe there's change in data. It will reflect automatically. And in the constructor, aside from injecting the milk service, we also initialize the chart register. This is just a syntax. I don't know why it works this way, but there's always an issue with the chart.js, and if you just initialize this way, then it will display as I will show after I'm done with this explanation. And then in this ng on init, which is a lifecycle hook of this component, we retrieve the weekly milk chart data and then subscribe them to a variable. I do call this a variable because that's the easiest way of like explaining this thing. So we assign that variable to the instance, or rather the property of this component, the this.data, and then we call the create chart. I have decided not to add the code of create chart here to make this more clear and visible, and also to make it easier to debug. And so before I explain the create chart method and its inner workings, we will have to look at the type of the data that is being returned from the database. And in this case, I've decided to use Postman because they just work the same way. It's only that Django REST framework has a brushable API. So for now, I just simply, it's a GET request, then send it to the database. And so this is the type of the data that is being returned from the database. Actually, it's a list of dictionaries. So now that we know that, I'll explain how the create chart works. First of all, we iterate through the first level of the values of the list. In this case, it will be the day's name because we have the day, that's a key, and then Monday, or rather if it could be Tuesday, Wednesday, Thursday, and all those stuff. So that's in the first level. And then to get the data sets, so we'll now dive deep into the other list of the other dictionaries. So what we do, we first of all create a variable, the let total milk is equal to 0, and then now we iterate through the other list of the dictionaries to get the milk records, and then we assign them, or rather we add them to the total milk. This will ensure that each and every day has the aggregated total milk correctly, and this is the easiest way to achieve this. And so for the fill, border color, tension, border width, all this is for the aesthetics. And then here also we just like specify basically the type of the chart and maybe other options. If you want to know more about all this, you can just go through the chart.js official documentation. They're just the same. Actually just copy pasted a lot of stuff and edited them, and now just customize them based on our requirement so that you can understand them better. But if you need to know more, you can just go into this website. There are quite a lot of explanation and different types of charts and how you can customize them. As you can see, there's the bar chart and etc. So with all this done, what we need to do is to go and check our website if it's working well and everything is okay. So I'll refresh our dashboard, and this our dashboard looks like. Oops, this image seems like it's broken. So what I'll simply do is go and check the name. Actually, this is in the dairy admin, and then it's in the dashboard because actually that's it's displaying in the dashboard. Then it's under the milk production. So I'll just simply check the HTML. So the HTML is looking for the milk-image.svg. This SVG file I just downloaded it from Pixabay. So this is in assets. So what? Okay, so the naming is the different things. So what I'll simply do is just rename this to milk image.svg and then save it like that. So we can check, refresh it. Wow, it displays now. So now that I only added a single milk record today of the 21 kgs, we have this. Then the herd count is here. For now, we only have 2 cows in our database. Then this is the female and this is the male. We only have 1 female cow and 1 male cow. Then now that we only have 1 record today, the cows that milk today is only 1. And because the milk record is always tied to the lactating cows, so the fact that we have 1 cow that is milked today, we also have to have 1 record of that cow as the lactating cow. So I'll go ahead and add another milk record for that cow, the cow number 2. Maybe make it 15, save it, and come and check. So I refresh this, and now you see we have the 36 kgs. And by the way, we had some checks, or rather I had some customizations that I just forgot to explain. So let me go to the milk production HTML. We have this, the ng class property. Remember, I had explained in the previous tutorial and in this tutorial that anything that is inside the brackets, that means that that's a property binding. And in this case, we are binding this class of the text green 500 into this div tag. So meaning that we are passing this percentage difference. So this percentage difference, remember that we had that straight from the views. So if it's greater than 0, we will make sure that the text here is bold, large, and also it's green in color. But if it's less than yesterday, we will make the text to be red in color. And then in this small span, we check if the percentage difference is less than 0. So if it's less than 0, we will append an hyphen to symbolize that it's a negative, or if it's greater than 0, it's a positive, meaning that it's an increased percentage. So this is what's happening. So now for now, it's just black because we do not have any data for yesterday. We only have one milk record. So what I'll simply do, now that we only have one single record, or rather we have two single records of today. I'm recording this in 20th March. What I'll simply do is just do some, this is crazy, but I'll just quickly use this to get the data set. So what we do, in order to make the data to be, now that today is Monday, if we return it to Sunday, it won't make any sense because Sunday was just the other week. So now that we're starting the week today, what I'll simply do is make the date of today to be 21st, that is tomorrow, and then simply go and add a new milk record of tomorrow. Then I just make it maybe 19 kilos and save it. So if we come back to this our front end, what we see now, you see now we have the 19 kgs because today, so it's 47.22% less than the yesterday's milk count. And then because today is 21st and actually you have a single record, it will also display a single milk record. And then our graph, because we only have 2 days now, that Monday, which is today, which is 20th as the time that I'm recording this, and then we've already added data for tomorrow, that is Tuesday. It does not make any sense, but if I go ahead and add another new data for maybe Wednesday 2, which will be 22nd, I'm just using this because this is one of the simplest ways of achieving what I want to explain. So maybe that day we have 30 for that cow. If we come here and refresh this, now you see we have the Monday, Tuesday, Wednesday. So this chart spans up to Monday to Sunday. And so the more you add the data, or the more the days progress by, it will have Monday to Sunday. So it will add that data dynamically. And so I think, wow. And for now, by the way, now that we have 30 kgs, and just the previous day we had 19 kgs, it is 57.89% more, and that's why the text is green. And so I think this is enough for this tutorial, and in the next tutorial we shall be building and actually making this admin dashboard more beautiful and adding more data and everything. For example, we'll also need to add a chart for a monthly milk production, also maybe have the list of the lactating cows, list of the milk cows today, and also I'll also build the about us and the contact us page. And so thank you for watching this tutorial up to this end. Like, share, subscribe, give me feedback in the comment section if you wish, or maybe if you see something that's questionable, or maybe if you want me to add something. And I'll see you in the next tutorial. Bye bye.